at question 2. It says a 60 centimeter long clarinet is played and the fifth harmonic is produced. The sound wave vibrates up and down with 45 cycles in 10 seconds. Determine the frequency, period, wavelength, and the speed for this wave. Okay, so they want us to find a few things. They want us to find 4 different things. They give us this diagram to help us out. This is the length of the clarinet. So this is the tubing of the clarinet. This is the 46 centimeter tubing of the clarinet. And this shows the standing wave that's inside of the clarinet. Let's start looking at the equations we can use. So wavelength equals total length divided by number of waves. So we have our total length, that's 60 centimeters. That part is pretty easy. Make sure you convert it into meters. I did it here. But now we have to figure out how many waves are drawn. So I'm going to highlight them in different colors. So I like using the equilibrium to every other equilibrium rule. So let's look at the blue line first. Equilibrium to every other equilibrium. So I know what's in blue is 1 wave. Now this portion, equilibrium to a crest, that's a quarter of a wave. It doesn't matter how you count it. You'll get a 1.25 waves every way you count it. It's always going to be a quarter. Even if you went and did the equilibrium, even if you went about it and did crest to crest. Here's one crest. Keep going. Here's another crest. So that's 1 wave. And now you have this quarter left. So no matter how you want to count it, you'll still end up with a quarter, 1.25 waves. So let me plug that in. Total length is 0.60 meters. The number of waves is 1.25. That gives me a wavelength of 0.48 meters. Now the rest of the problem is pretty simple. So now we can use this formula. We know the wavelength. They gave us the frequency. It says 45 cycles in 10 seconds. We can find the frequency with that. Finding the speed is super simple at that point because you have the wavelength and you would have found the frequency. Just solve for V. Find out the speed of the wave in this tube. And then that's it. You're all done.